Here's one of the lessons from our Yachtmaster online shore-based course. This one is on chart projections. Before we get into the chart, let's look at chart projections. There are many types of chart projection, from cylindrical to conic to azimuthal, which is all very well, but there are only two that we come across in navigation, and they are the Mercator Projection, which is a cylindrical projection, and the mnemonic projection, which is azimuthal. You see, the Earth is round. Well, actually, it's an oblate spheroid, so round but a bit squashed at the top and bottom. And to be able to plot positions, we need it to be flat. And it was Gerardus Mercator, a pioneer in cartography in the 16th century, who took this oblate spheroid and presented it on a flat paper chart. He did it with ellipsoids and algorithms, but in essence it was as if he had shone a light from within the Earth and projected an image onto a flat wall and drawn a chart from this. The result of this was that the nearer you got to the poles, the greater the distortion, which is why on a Mercator projection chart, Greenland is shown as being much bigger and wider than it really is. Here it looks as though it's the same size as South America, when in actual fact South America is 8 times larger than Greenland. This also means that we need to measure distance on the latitude scale beside where we're working on the chart. Here on a chart of the North Atlantic you can see clearly that if we were sailing north of Scotland and measured our distance off the latitude scale down by North Africa, we would be way out. Mercator also made measurements and drew up charts with the Earth on its side, and this is called transverse Mercator. And transverse Mercator is used on large-scale charts of 1 to 25,000 or less, which cover a small area, a port or harbour, for example, because transverse Mercator provides greater accuracy over small distances than standard Mercator. Here, for example, is a chart of the Crouch and Roach rivers on the east coast of Britain, where the scales are between 1 to 10,000 and 1 to 25,000, and you can see that the projection is transverse Mercator. Now, with Mercator's projection, the lines of meridian go straight up the chart, and if you were to draw a straight line that cut one or more of the meridians, it would be cutting each at the same angle, and this is referred to as a rhumb line. So when we draw our course on a Mercator chart and sail down this line, we are sailing down the rhumb line. Now, Mercator projection charts are perfectly good when you're sailing short distances, but they don't actually take you on the shortest route when it comes to sailing long distances around a globe. And that is why, when sailing long distances, we use a chart with a mnemonic projection, where the lines of meridian converge towards the poles, and we work to what are called great circle routes. Synoptic weather maps for the Met Office use mnemonic charts, and you'll see these in Module 10. Now, to sail a great circle route would mean having to change course very slightly the whole time, which is not practical. So we map out the great circle route and then break it down into smaller waypoints that we can sail directly to along the rhumb line, the bearing of each waypoint changing slightly, so we're following a great circle route, but in a series of shorter straight lines. This is referred to as composite sailing. We have programs that can work this out for us, or we can refer to astronavigation and the local hour angles of the start and destination points and work it out ourselves. Here's an example. Sailing from Land's End to the Caribbean, a straight line Mercator course would be 245 degrees, whereas a great circle route sets us off at 265 degrees, and so we ask the computer what courses we need to follow, assuming we change course every 10 degrees of longitude, and this is what it gives us. 10 degrees of longitude on this course is about 400 miles, and so we'll be sailing a series of rhumb line courses, each of which will take us 3 days, and each of which will change by about 7 degrees at the start, and then by about 4 degrees at the end. Notice how adopting a great circle approach takes us north of the rhumb line. The rhumb line course would have been 245 degrees, and the great circle is 265 degrees. This becomes important when sailing west to North America, in case a great circle route might take one too far north into an ice zone. Every now and then you'll find a large-scale chart covering a very small area that uses the mnemonic projection. Here is one of the approaches to St Helier in Jersey. It runs from 2 degrees and 1 minute west to 2 degrees 21 minutes west, so a very small area, just 20 minutes of longitude. And I've checked. Although the meridians on a mnemonic chart converge towards the poles, as they would on this chart if we zoomed out to make it a small-scale chart covering a large area of the Earth, the meridians on this tiny, minuscule section of the world at this point are apparently parallel. I've measured them, and so we can use it just like a Mercator chart. Relating chart projections to the electronic charts that we'll talk about later in the course, we have raster charts, which are digital copies of the paper chart, and the projection on the raster chart will be the same as the original. Vector charts, or ENCs as they're also called, standing for Electronic Navigational Chart, no prizes for guessing that one, do not use a projection. They are a database of images and locations which are populated against a geodetic model of the world. There are various datums that they can match: Ordnance Survey Great Britain 1936, European datum 1950, but the one which everyone is working towards is World Geodetic System 1984, WGS 84. And as long as the datum in your chart plotter matches that of your chart, you can place positions from the chart plotter onto the paper chart with confidence. ENCs do not have symbols that match exactly what you'll see on a paper chart or its electronic equivalent, the raster chart, which work to the standard of INT1 symbols, which you'll find in the Admiralty's Chart 5011, but they're very similar. I've mentioned local hour angles for measuring distance here, and that belongs on the Ocean Master course, as do Great Circle routes. We don't need to work with any of this at Yachtmaster, but you need to know it exists. And now you do. Remember, you can try before you buy with our free previews, so go to westviewsailing.co.uk.